whenever I'm doing problems with ASCII, I usually just go to ASCIItable.com because usually because I Google it and it's the first result, and two because I really like the cheap perfume that they have advertisements for. It's the best in the UK, and what can I say? I'm just kidding. Anyway, so this is the way the ASCII table is organized. A bunch of people got together and said, "Hey, what's the best way to do this?" And this is what they arrived at. So the standard ASCII table that you look at here, this is just 7 bits, right? 0 through 127. And actually, here, this is your extended ASCII codes. So you've got some special characters here. They're like, yeah, let's throw in the fraction, 1/2 and 1/4. And also, some Greek characters, and these are also for building user interfaces. Like you think like old text-based programs, and these are actually even for rendering images. Extended ASCII, it's interesting, but we're not too worried about it. Sorry, one more thing, just for pop culture, or not pop culture, but just trivia stuff here, right? 1/2 and 1/4. It seems crazy that those fractions are put on there. But a lot of the characters that are available, they kind of take inspiration from what was available pre-ASCII or pre-computers, and that was what was on typewriters. And on typewriters, you would actually see, not extremely commonly, but once in a while, you would see 1/2 and 1/4 on typewriters. So this is kind of something interesting. Anyway, it's the bulk here. What we really want to look at is the way this table is organized. And so it's kind of split into 4 columns, right? We've got 0 through 1, 2 through 3, 4 through 5, and 6 through 7. So I'm talking about the most significant hex digit here. And so column 1, it's actually just a bunch of control characters, right? So we've got these things like shift in, shift out, acknowledge, bell, backspace. So those are all characters that might tell a printer what to do or help sort out the way your document looks or whatever. And then here we have a bunch of punctuation stuff. We got our space there, and the big thing is we've got our numbers here. We've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the numerical representations, right? These don't necessarily represent values. Those are just the symbols. And the key thing here is that they placed 0 starting right here at hex 30, and then you've got 31, 32, 33, 34. So they put it there so it's easy to get the value of the digit because you can just subtract hex 30. And then here's our capital A, right? We start at 41. I'm not entirely sure why they didn't start right at 40. But anyway, so you got 41 is capital A, 42 is capital B, so on and so forth. And then right across the border here, we've got 61 is lowercase a, and 62 is lowercase b. And so that means that if you want to go from uppercase to lowercase, you just need to add hex 20 or subtract hex 20, or it turns out to just be, what, I think bit 7 that you just need to flip around. I can't remember, 7 or 6, but it's one of the bits that you can see that just needs to be inverted if you want to go from uppercase to lowercase. So that's another convenient thing. And so the big things that they wanted to be able to place is where the numbers and the letters are, and all your punctuation is not super important where it's at, and so they just put it in convenient spots. So those are just some of the key things to notice from the way that the ASCII table is organized.